Hi, Assalamualaikum. In this video, we are going to continue with example 2 and the mean value theorem for integrals. The mean value theorem for integrals said that if fx is continuous on a closed interval ab, then there exists at least one number c in closed interval ab such that integration from a to b fx dx equals to fc times b minus a. If fx equals to 1 over square root of x minus 1, find the value of c in the interval 1, 5. Right? This is the given question. Right? Before that, to check whether the value of c is correct or wrong, c must be between the given interval 1 and 5. Right? Right, to solve this question, first, we need to use the given formula. So we jump to step 4. Use integration from a to b fx dx equals to fc times b minus a to find the value of c. Right? Right, before we use this formula, first, step 1, we need to identify the values of a, b, and b minus a to substitute into this formula, right? And then step 2, from the given fx here, we need to find fc to substitute into this formula, right? Then step 3, find integration from a to b fx dx to substitute into the left-hand side formula, right? Right, now we look at one by one. Okay, find the values of a, b, and b minus a. Okay, 1 here, okay, means the value of a. Right, we compare from the closed interval here. Right, so a equals to 1, b equals to 5. Okay, so we write here, and after that, we need to find the value of b minus a to substitute into this formula. So b minus a equals to 5 minus 1, which is equals to 4. Right? Right, after that, step 2, we need to find fc from fx. Okay, fx here equals to 1 over square root of x minus 1. Right? To find fc, we just replace x by c here, right? Right, now we continue with step 3. Find integration from a to b fx dx, right? So from here, integration from a to b fx dx equals to, we replace a, okay, equals to 1, okay? And then we replace b equals to 5. We replace fx equals to 1 over square root of x minus 1 and then dx here. Okay, so now we have integration from 1 to 5, 1 over square root of x minus 1 dx. Okay, this is definite integral. So how to integrate this function? Right, first we need to change into the form of indices. Okay, using the properties of indices, we can write 1 over square root of x minus 1 equals to bracket x minus 1 to the power of negative half. Right? Right, negative half here comes from square root of x minus 1 here from denominator here means x minus 1 to the power of positive half in denominator. Under properties of indices, we can move up, but the power should be negative or the exponent should be negative when we move up. Right? Got it? Right, from here we have in bracket is linear function, and then to the power of negative half. Negative half here means n, or the power of the given function here, not equals to negative 1. Okay, what happened when n not equals to negative 1? Okay, we can use power rule. From this formula, if we have integration of linear function to the power of n, where n not equals to negative 1 means any value except negative 1, okay, we can use this formula. Okay, 1 over a times linear function and then n plus 1 over n plus 1 plus c, right? So using this formula, so after we integrate, no more integration sign, okay, then we have 1 over 1, okay. How we get this? From this, 1 over a. Okay, a here means the coefficient of x. Okay, coefficient of x here means 1. So that's why we get 1 over 1, right? And then times, we have linear function here, okay? And then to the power of n plus 1, okay, over n plus 1. So from here, our n equals to negative half, okay? Negative half plus 1 equals to positive half, right? And then over n plus 1 means over half, right? Alright, this is indefinite integral, so we need to put plus c at the back, right? But in this case, we have definite integral. So when we solve definite integral, no need to put plus c, but we need to use square bracket with lower limit and upper limit, right? Right, from here, we can simplify and we get this, okay? How we get this? From over half here, okay, this is constant, so we can move out, okay? Over half here means times 2 over 1, which is 2, right? Then we can write bracket x minus 1 to the power of half equals to square root of x minus 1, right? From here, we can replace upper limit 5 into x here, okay? So we get 5 minus 1, which is 4, and square root of 4 equals to 2. And then in between is minus, and then we replace lower limit 1 into whatever x here. So we get 1 minus 1, which is 0. Square root of 0 equals to 0. Okay, and we still have constant 2 outside here, right? So after we simplify, we get 4. Okay, integration from a to b fx dx equals to 4, right? We recall back, we integrate this function using this formula, right? This formula is given in the previous video under topic integration by U substitution. Okay, you can check it, right? Or from here, we can use U substitution, okay, to integrate this function. Okay, we choose U equals to the function in bracket, which is x minus 1. And before that, every time when we use integration using U substitution, we will have derivative part and integration part. Alright, under derivative part, we need to differentiate. Alright, from U equals to x minus 1, we need to differentiate U with respect to x. So the symbol is du over dx. Okay, and we differentiate x equals to 1. We differentiate negative 1 equals to 0. Okay, no need to write. And after that, we need to write dx as a subject. So after we cross multiply, so we get dx equals to du. Alright? When we use U substitution, we need to change all the variable here in terms of U and du. Right? Right. So from here, we get integration from 0 to 4, and then U here means x minus 1, or x minus 1 means U, and then to the power of half, our dx equals to du. Before that, how we get this? Okay, we will discuss later. Right? Right. From here, now we have integration of U. Okay, and we have x here, okay, equals to 5. Okay, from the given function here, we have x minus 1. Okay, means upper limit here is the value of x. Okay, and then now we have in terms of u and du. Okay, so we need to find the new upper limit for variable u. So that's why we get this. Okay, u equals to 4. But how we get u equals to 4? From here. Okay, we substitute into here. When x equals to 5, we substitute here. So we get u equals to 5 minus 1. So we get u equals to 4. Okay, this is our new upper limit for variable u. Right? And then from here, since we have variable x here, means the lower limit here equals to the value of x, means x equals to 1 for the lower limit. Okay, then we need to find the new lower limit. Okay, how we get 0? 0 here means the value of u. Okay, from here, we substitute 1 into u here, into variable x here. So we get u equals to 1 minus 1. Okay, so we have u equals to 0. Right? When we have variable x, we need to use lower and upper limit for variable x. And when we use variable u, we need to use lower and upper limit for variable u. Right? Got it? From here, we have all terms containing u and du here. Okay? And we have lower and upper limit for variable u. So we can integrate. Okay? To integrate u to the power of negative half du, first we look at this power. Okay? We have negative half here. Means n not equals to negative 1. Okay? From this formula, if we have integration of u to the power of n du, where n not equals to 1, means any value except negative 1, so after we integrate, we have u to the power of u to the power of n plus 1 over n plus 1. Since this is indefinite integral, so we must put plus c. Okay, this formula is given in the previous video in topic integration with u substitution. Right? Right, so using this formula, so we get u to the power of half. How we get half here? Because n, which is negative half, plus 1. So we get positive half here. And then over n plus 1 means over negative half plus 1, which is equals to half. Alright? And then when we integrate definite integral, no need to put plus c, but we must put square bracket with lower limit and upper limit. Right? Alright, from the previous slide, we get this. Integration from a to b fx dx equals to u to the power of half over half. And then square bracket from 0 to 4. Right? Right, then we can write this. Okay? U to the power of half means square root of u. And then over half here, we can change to multiplication. Means multiply by 2 over 1. Okay, that's why we have 2 here. And since this is constant, so we can move out, right? Right, after that, we have integration from a to b fx dx equals to 2. We substitute upper limit first into u here. We can straightforward substitute 4 into u here because 4 and 0 here are the values of u. Okay? Right, so from here, we have square root of 4 after we replace upper limit 4, and then in between must minus, and then we replace lower limit 0 into u here, so we get square root of 0. Okay, then we have 2 times 2 minus 0, which is equals to 4, right? So we have two methods to integrate u to the power of negative half here from the previous slide. Either we can use integration of linear function or we can use u substitution, right? From the previous slide, under step 3, we get integration from a to b fx dx equals to 4. Okay, and we recall back under step 1, we have b minus a equals to 4. And from step 2, in the previous slide, we get fc equals to 1 over square root of c minus 1, right? Now we continue with step 4. Use integration from a to b fx dx equals to fc times b minus a. Okay, integration from a to b fx dx we find in step 3. fc we find in step 2. And b minus a we find in step 1, right? So we substitute 1 by 1, okay, using this formula. Okay, integration from a to b fx dx equals to 4 from step 3, and then equals to fc equals to 1 over square root of c minus 1 times b minus a equals to 4, right? Then from here, we have 1 equals to 1 over square root of c minus 1. How we get this? We have multiplication of 4 here. So when we move to left-hand side, so we get 4 divided by 4, which is equals to 1, right? Then from here, we just cross multiply. So we get square root of c minus 1 equals to 1, right? Right, from the previous slide, under step 4, we get square root of c minus 1 equals to 1. Okay, then we can move square root here to right-hand side. So we get c minus 1 equals to 1 squared. Okay, so we have c minus 1 equals to 1 squared equals to 1. So c equals to 2, right? Then we check from the given interval here. Okay, c equals to 2 is valid in the interval 1, 5. Okay, means c equals to 2 is the correct answer, right? Got it? Coming up next, more examples for mean value theorem for integrals. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.